Okay, combinations of transformations practice, homework. So describe the transformations that must be applied to the base function f at x to obtain the following transformations. Okay, so f at x is our base, which in this case is x squared. This doesn't actually even matter because all we're doing is writing the transformations. So what does this 3 mean? And we're going to go through every single number that's added to like this equation. Okay, so the 3 means vertical stretch. I'm going to say by 3. So it's like by a factor of 3. Okay, this means that we go right 1. And this means that we go down 2. So something like this would be out of 3 marks. Okay, 1 mark for each transformation. Now, B is a little bit different because we have, this darker, we have 2 over 3, and then we have our F, but the thing is, in here, we actually have to factor out the 1/2. So if we common factored out a half, we have x minus 12. It's like, how many halves are in 6? Well, there's 12 halves. And at that point, we can state all the transformations. Okay, it has to be in this factored form in order to actually read. Like the horizontal reflection or stretch or compression, you're going to read that correctly. What's going to actually change is that third number. So this 6, like the -6, changed to a -12. Okay, so that's the one that you're going to go wrong with. So the first number is 2/3. This is a vertical compression by a factor of 2/3. Okay, this 1/2 is a horizontal stretch by a factor of 2. Now this 12 goes right 12, and the 5 goes up 5. Okay, we're on C. So the function's 1 over x. This doesn't even actually matter. What matters are this 2, the negative symbol here, and the -7. So the 2 stands for a vertical stretch by a factor of 2. The negative sign right beside the x is a reflection in the y-axis. And this -7 is down 7. Okay, D is like B, where we have to carry down the -5, but under this bracket here, or the root symbol, we have to actually factor out a 2. So if we common factor it at 2, we would get 2. I don't like how close this is together. That makes leave some room. Okay, factor out a 2, we get -5 bracket 2 as our common factor, and then we get x minus 7 over 2, and then plus 3. Okay, so now we state all the transformations. The negative symbol is a reflection on the x-axis. Okay, oh, the 5 is a vertical stretch by a factor of 5. The 2 is a horizontal compression. Remember, that one is opposite to what it looks like. So it looks like a 2, it's actually 1/2. Okay, so it's a reciprocal. Horizontal compression by a factor of 1/2. We're going right 7 over 2. And then we're going to go down 3. Which is this one, or this one right here. Okay, describe the transformations applied to the base square root function. So the base square root function is just f at x equals root x. Okay, so that's the base function, no transformations on it. And now we want to know how is this transformed, that we got g at x equals -2 root x minus 3 plus 4. Okay, so I'm going to do that in along with b as well. So determine the values of a, k, h, and c. So let's do this and then let's write them in order. Okay, so the a value is -2. This is both a reflection in the x-axis and it's a vertical stretch by a factor of 2. Okay, k is 1, so there's no horizontal, there's like no change here, horizontal stretch or compression. Okay, the next number is 3. So h is actually 3 because there's that built-in negative sign. So that means we go to the right 3. And this is 4. C is 4, so we go up 4. Okay, so now we're going to use the key points to stretch this graph. Stretch, compress, and apply transformations. Okay, so when we're dealing with a root function, we want to use 0, 0, 1, 1, 4, 2. And we write the mapping notation based on what's actually going on here. Okay, so there's a reflection in the x-axis and a vertical stretch by a factor of 2. So we get -2y. And then that's also going up 4. For the x values, it's only going right 3. So let's take every single x value and add 3 to it. And let's take every single y value, multiply it by -2, and then add 4. So -2 plus 4, and then -4 plus 4 is 0. So we can go ahead. I'm going to make the scale by 1s. Okay, so I'm just going to have 1 here and 1 here. That implies the entire scale is like going up by 1s each time. So we need to plot 3, 4. So 1, 2, 3, 1, 2, 3, 4. That's going to be our starting point. We're going to go 4, 2, and then 5, 6, 7, 0. Okay, so the question is, which side of this do I put my arrow on? Well, it's going to be this side. And the reason why it's going to be this side is because this, like the starting point here, corresponds to 3, 4. So that one wouldn't have the arrow on it. Okay, so same type of question. Determine the values of A, K, D, and C. So A, K, D, and C for this function here. And then I'm going to describe the transformations applied. I'm going to do this in order. If you write these down in this order, they're in order anyways. Also, it's not so self-explanatory with this function, like the 1 over x function, but when you go through a function and you actually go from left to right, the transformations are in order already. Okay, so if we're looking at g at x equals 1 over 0.5x plus 3 minus 2, we notice that in the denominator here, the -0.5 is not factored. So we actually have to factor that out to see if this is going left or right, and then how many units as well. Okay, so just the number in front of the x has to be factored. So I get x plus 6. Okay, so this is the actual equation we're going to base our graph on. Okay, just the factored form. So a is this number on top, or it could be written in front in the numerator, and a is just 1, so no change. Okay, our k value is in front of this bracket, so our k value, if you put it as 0.5 or because 0.5 is just 1/2, if you put it as 2, that's okay too. Okay, so it's technically 2, and this is a horizontal stretch by a factor of 2. Okay, D is -6, is going left 6. Okay, in this bracket, it looks like a positive, so D is actually the opposite. And then -2 is down 2. Okay, so for the 1 over x function, what we want to use for our base is -1, -1, 1, 1. And then we also want to state the horizontal asymptote and the vertical asymptote. The original horizontal asymptote is at y equals 0, and the original vertical asymptote is at x equals 0. Okay, so now what's going on in this graph? So for the x's, there's a stretch, so 2x, and we're also going left 6. For the y's, no change and then down 2, so y -2. Okay, get that off there. Okay, so we take these two values and we sub them in this x here. So -2 minus 6 is -8, and 2 minus 6 is -4. Okay, now we take these y values and we sub them into where this y is. So -1 minus 2 is -3, and 1 minus 2 is -1. So here's the thing. For the vertical and horizontal asymptotes, we can technically take, oh, y is 0, so we sub it in here. 0 minus 2, our new asymptote is -2. Or we can just say, oh, it's down 2. Our asymptote here is exactly what we're going to have in this position. It's going to be the up-down movement. Okay, vertical asymptote, we have x equals 0. So we technically take that 0, we plug it into the x value, like the transformation, and we get -6. Okay, the x value is also what we're going to have here after it's factored. Okay, it's going to be the left right. So I'm going to draw this right in the middle. We're going to use a scale of 1. So the horizontal asymptote is -2. So we put a dotted line here, and we put y equals -2. The vertical asymptote is 1, 2, 3, 4, 5, 6, is -6. So we put a vertical dotted line, x equals -6. Okay, and if we put -8, -3, we're going to get a point here, which means that our graph's going to look like that. And -4, -1, we're going to get a point here, which means our graph's also going to look like this. So we should, along these two asymptotes here, this is the intersection of the two asymptotes, we should get 1 point on either side, like kitty corner to one another.